Let's continue example 5.3. So in example 5.3, we would like to identify the purge rate that can give us the ammonia with the mole fraction of 0.96. And also we would like to investigate the effect of the feed temperature to the ammonia mole fraction and also molar flow rate in the fresh drum. So in order to identify the best purge rate to give the ammonia with the desired purity, we have to use design spec. So you have to go to flow sheeting. Okay, just start from the previous example 5.2. You have the flow sheet with the closed loop. So from there, you can start the flow sheeting option, create a design spec, okay, create a new design spec, DS1. So what you need to do here, you have to first define our target. Okay, our target is the mole fraction of ammonia, so NH3 fraction. So this is a stream under the stream category, and is mole fraction. B stream, it is liquid ammonia, the product stream. So the component is ammonia. So then we have actually defined that this is our targeted parameter, the mole fraction of ammonia. So here you can right click and include the variable, just drag the variables, just drag, or you can also type the name here, but make sure it's exactly with the name that you define in the define tab. Okay. And then target is 0.96, the mole fraction, and the tolerance it can be 0.0001, okay, or even 0.001. So the vary tab, under the vary tab, you would like to vary the purge rate of the splitter. So it's a block variance. Which block? S100. The variable is the split fraction for the purge stream. Okay. We would like to vary from 0.01 to 1. And step size, you can include it or you can just leave it. Let's say you would like to include the step size of 0.001, then you just include, and you can now run it. Okay, so under the design spec, you can check the results. Okay, so the required purge rate is in fraction basis is 0.0248. 248, okay, 0.0248, in order to give you the ammonia with the mole fraction of 0.96. Okay, in percentage is 2.48%. So then we have actually identified the purge rate that can give us the product ammonia with the mole fraction of 0.96. So we proceed to the next one. The next one is to investigate the effect of the feed temperature of the fresh drum to the mole fraction and also the molar flow rate of ammonia. So what you need to do is you have to deactivate the design spec, because in order to proceed to the question B, we need to use sensitivity study to study the effect of the feed temperature of the fresh drum to the molar flow rate and also the mole fraction of ammonia. Okay. So once we have deactivate the design spec, you move to model analysis tools. Sensitivity study is under the model analysis tools. So create a new one. We have S1. Okay. So vary, the first one, under the input of S1, you have to include the vary parameters. So we would like to just click new, and we have to vary the feed temperature, and the feed temperature is relying on the cooler temperature, which is E101. So it is actually the block variance, because we would like to vary the temperature of E101, the cooler. Variable is temperature in Kelvin. So the temperature, I think we have to vary from, let me see, 300 to 350. 300 to 350. Okay. And the number of points is, okay, you just put 10. So the vary tab is done. We move to define tab. So under define tab, you have to define the parameters that you would like to observe by varying the feed temperature of the flash drum. So click new, enter the name. So the first one is the ammonia fraction. We would like to observe these parameters. So it's a stream information. Type is MOFRAC. Stream is the liquid ammonia. Component, of course, is ammonia. Okay. So the second one, we would like to observe the ammonia molar flow rate. Okay. So please make sure you define the ammonia molar flow rate. It's a stream information, and this is mole flow, and it is a mole flow of ammonia in the liquid ammonia. Okay. Done also. We move to the next step, tabulate. Just click on field variables, and the table will be listed with the parameters that we have included in the define tab. So we have got all the information to proceed for the simulation. So once this is done, under the sensitivity folder, you can have the results folder as well. So this is the ammonia mole fraction and ammonia flow rate with respect to the different temperature from 300 to 350. So other than the table, you can also plot the graph. You can click custom. So the x-axis would be the temperature, okay, and the y-axis would be the ammonia mole fraction and the ammonia molar flow rate. So click OK. So this graph will be generated. So obviously the feed temperature of the flash drum is having a significant impact on the purity of the ammonia and also the molar flow rate of the ammonia. Okay, that's why we have to control the feed temperature of the flash drum properly in order to get the product with the desired amount and desired purity. So of course, after all the simulation, you will need to save your file. Okay, just save the file to the designated place. Okay, just make sure you put in the proper folder, and you know the location of the file. Just save it. Okay. So I think we have done for example 5.3. I hope you enjoy the simulation process. Thank you very much.